Hello everyone, my name is Karthik Suresh. I am a student of SCC College Mechatronics Department. This video is on a technical seminar on turbocharged engines. Mm, The contents of this presentation is abstract, introduction, objectives, problem statement, literature survey, turbocharged engines, applications, advantages, drawbacks, conclusion, and references. First is the abstract. Turbocharged engines have become increasingly popular in the automotive industry due to their ability to increase horsepower and torque while also improving fuel efficiency. This seminar provides an overview of how turbochargers work and the different types of turbochargers, as well as their applications in high performance cars, trucks, and motorcycles, as well as in diesel engines. The seminar also covers the technical challenges involved in designing and manufacturing turbocharged engines and future developments in turbocharger technology. Through this seminar, we will gain a comprehensive understanding of the benefits, applications, and potential future advancements of turbocharged engines. Introduction Introduction to turbocharged engines. Turbocharged engines have become popular in the automotive industry, and a turbo the automotive industry ability to increase engine performance while also improving the fuel efficiency. A turbocharger is a device that compresses the air that enters the engine, allowing it to burn more fuel and create more power. The result is increased horsepower and torque, as well as improved fuel economy. In recent years, turbocharged engines have been used in a wide range of vehicles, including high performance cars, trucks, and motorcycles, as well as in some diesel engines. They are also becoming more popular in mainstream vehicles as automakers seek to improve fuel efficiency and reduce emissions without sacrificing performance. The objectives to explain the basic components of a turbocharger and how it works to increase engine performance and fuel efficiency. To provide an overview of the different types of turbochargers and their applications in various types of vehicles, including high performance cars, trucks, and motorcycles, as well as in diesel engines and emerging applications in mainstream vehicles. To highlight the advantages and disadvantages of using a turbocharged engine, including the technical challenges involved in designing and manufacturing them, such as heat management and durability. To discuss ongoing research and development in turbocharger technology, including potential future advancements and applications, such as electric turbochargers and variable geometry turbochargers. Now, what are the problem statements? So, while turbocharged engines offer many benefits such as increased horsepower and torque and improved fuel efficiency, they also present several technical challenges for the designers and manufacturers. These challenges include heat management, durability, and maintaining proper air to fuel ratios. Additionally, the increased complexity of turbocharged engines can make them more difficult and expensive to repair and maintain. Furthermore, as turbocharged engines have become more popular in mainstream vehicles, there is a need for ongoing research and development in turbocharger technology to address these challenges and make them reliable and efficient. These are the papers of that referred to in making the PPT on this topic. The first paper is by the author called M. A. L. Syed. This paper was published in the year 2017. The title was given as a review of turbocharger technologies. This paper provides a comprehensive review of the different types of turbocharger technologies, including fixed geometry, variable geometry, and electric turbochargers. The second paper was published in the year 2018 by CM Baines and RWA Owlet. The title was given as Turbocharging the Gasoline Engine Evolution or Revolution. This paper explores the history and current state of turbocharging in gasoline engines and discusses the challenges and opportunities for future developments. The third paper was published in the year 2018 by SM Al Zubaidi, MY Hassan, and H.A. Aziz. The title was given as Turbocharger Matching for Engine Performance Improvement. This paper presents a method for optimizing the matching between a turbocharger and an engine in order to achieve maximum performance and efficiency. The fourth paper was published in the year 2019 by El Martinez Sanchez, E. Blanco Marigorota, and M. In this paper's title was given as Advances in Turbocharger, Compressor, and Turbine in Design. This paper provides an overview of recent advances in the design of turbocharger compressors and turbines. Turbocharged engines. Turbocharged engines. Turbocharged engines are the turbocharged engines use a turbocharger to increase the amount of air that is delivered to the engine. The turbocharger is a device that uses exhaust gas energy to drive a compressor that forces more air into the engine cylinder. Turbocharged engines are widely used in a variety of applications, from passenger cars and trucks to high performance racing vehicles and heavy duty industrial equipment. Basically, a turbocharged engines are internal combustion engines that use a turbocharger to increase the amount of air that is delivered to the engine. It is also it can also be defined as a device that uses exhaust gas energy to drive a compressor that forces more air into the engine cylinder. By increasing the amount of air that is available for combustion, the engine can burn more fuel and produce more power. Working of a turbocharged engine. The working principle of turbocharged engines can be seen with the use of a turbocharger, which is a device that utilizes exhaust gas energy to drive the compressor. The compressor forces more air into the engine cylinder, allowing for more fuel to be burned and more power to be produced. The process of turbocharging begins with the exhaust gases leaving the engine, which pass through the turbocharger's turbine. The exhaust gas energy drives the turbine, which in turn drives the compressor. The, as the compressor moves, forces more air into the engine, the air is compressed, resulting in an increase in air density. This allows more air, fuel to be burned in the engine, which leads to increased output. So, as you can see, this is a video, and here it shows the working of a turbocharged engine. The compressor inlet is the inlet for the air to pass, and then it from the inlet it goes into the compressor discharge, where the discharge of the air is taking place, and air cooler is set to cool the engine. The intake manifold of the turbocharged engine is seen here. While the valve opens, the air is pushed inside, and exhaust manifold is the outlet air, and the exhaust turbine exhaust is the air outlet. The turbocharger operates at a high speed and temperatures and requires proper lubrication and cooling to ensure reliable and efficient operation. This is typically achieved through the use of engine oil and a dedicated cooling system. One of the advantages of turbocharging is that it allows for smaller, more efficient engines to produce the same power as larger, naturally aspirated engines. This leads to improved fuel efficiency and reduced emissions as well as increased performance and acceleration. However, turbocharging also presents some challenges and potential drawbacks, such as increased complexity, cost, and heat generation. Proper design and optimization of the turbocharging system is therefore crucial to ensure maximum performance, efficiency, and durability. Now let's come to the components of a turbocharged engine. The first basic component of a turbocharged engine is a turbocharger. The turbocharger is the key component. Uh, the turbocharger is the key component of the turbocharged engine, consisting of a turbine and a compressor that are connected by a shaft. Basically, the turbine is driven by exhaust gases from the engine, which in turn drives the compressor to deliver more air into the engine cylinder. The next component of the turbocharged engine is an intercooler. It is a heat exchanger that cools the compressed air before it enters the engine cylinders. This helps to increase air density and improve engine performance while also reducing the risk of engine damage from excessive heat. Wastegate. The wastegate is a valve that controls the amount of exhaust gas that flows through the turbine, and therefore the speed of the turbine and the amount of boost generated by the compressor. This helps to regulate the turbocharger and prevent overboosting and underboosting. Air intake system. The air intake system delivers air to the turbocharger, which is then compressed and delivered to the engine's cylinders. This system may include air filters, intake ducts, and sensors to monitor the air flow and temperature. Exhaust system. The exhaust system is responsible for directing the exhaust gases from the engine to the turbocharger and then to the atmosphere. It may include components such as exhaust manifolds, catalytic converters, and mufflers. Engine management system. The engine management system is responsible for controlling the operation of the turbocharged engine, including the turbocharger, fuel injection, and ignition timing. This system may include sensors and control modules to monitor various engine parameters and adjust the engine performance accordingly. Now, let us see the types of turbocharged engines. The first is single turbo. A single turbo setup uses uses a single turbocharger to deliver increased airflow and power to the engine. This is the most common type of turbocharged engine as it is relatively simple and cost effective to implement. But single turbo setups may suffer from turbo lag and reduced performance at low engine speeds. The next type is twin turbo. A twin turbo setup uses two turbochargers, usually of different sizes, to provide improved performance and responsiveness compared to a single turbo setup. By using two turbochargers, one can be optimized for low speed performance and the other for high speed performance, resulting in improved overall engine performance. The next one is sequential turbo. A sequential turbo uses two turbochargers, but they are used sequentially rather than in parallel. One turbocharger is typically smaller and optimized for low speed performance, while the other is optimized for high speed performance. The smaller turbocharger is used at low engine speeds to reduce turbo lag, and the larger turbocharger is activated at higher engine speeds to provide increased power and performance. The next one is variable geometry turbo. A variable geometry turbo uses adjustable vanes in the housing to control the speed and flow of exhaust gases, allowing the turbocharger to provide optimal performance across a wide range of engine speeds. VGTs can provide improved responsiveness and reduced turbo lag compared to fixed geometry turbochargers, but they are typically more expensive and complex to implement. Electric turbochargers are the next type of turbocharger. They are the recent type of turbochargers and modern technology usage. An electric turbocharger uses an electric motor to spin the compressor wheel rather than relying on exhaust gases to drive the turbine. This allows the turbocharger to provide boost more quickly and efficiently, as well as providing the potential for regenerative braking and other energy saving features. Implementation of a turbocharger. The engine must be designed or modified to accommodate a turbocharger, including changes to the intake and exhaust system, fuel injection, and other components. Turbocharger selection. The appropriate type and size of turbocharger must be selected based on the engine's characteristics and performance goals. Installation. The turbocharger and associated components must be installed in the engine, including the intercooler, wastegate, and boost control. Tuning. The engine management system must be tuned to optimize the performance of the turbocharged engine, including adjustments to the fuel injection, timing, ignition timing, and boost pressure. Testing and refinement. The turbocharged engine must be tested and refined to ensure that it meets performance and reliability requirements, including durability testing and real world driving tests. These are some of the applications of the turbocharged engine. They are used in high performance cars. Turbocharged engines are commonly used in high performance cars to provide increased horsepower and torque without sacrificing the fuel efficiency. Turbocharged engines can help improve the power and towing capacity of trucks, making them more suitable for heavy duty tasks. They are also used in motorcycles and to provide increased power and acceleration, making them more suitable for racing and high speed riding. They are used in diesel engines as well to improve their efficiency and reduce emissions. They are also used in mainstream vehicles as automakers seek to improve the fuel efficiency and reduce emissions in mainstream vehicles. Turbocharged engines are becoming more common as a way to boost engine power while still achieving higher fuel economy. They are also used in hybrid cars to help boost their performance and reduce emissions by providing additional power to the supplement the electric motor. Electric cars. While electric cars do not have traditional engines, electric turbochargers are being developed as a way to provide additional power and improve acceleration. Advantages of a turbocharger: increased horsepower and torque. Pro- they provide more power per unit of engine displacement, resulting in increased horsepower and torque. Improved fuel efficiency. The turbocharged engines can achieve better fuel efficiency compared to naturally aspirated engines of similar size due to the increased air intake and combustion efficiency. Reduced emissions. By improving combustion efficiency, turbocharged engines can also help reduce emissions, particularly in diesel engines where emissions regulations are more stringent. Enhanced driving experience. The improved power and acceleration provided by the turbocharged engines can enhance the overall driving experience, particularly in high performance cars or vehicles used for towing or hauling heavy loads. These are some of the drawbacks of a turbocharged engine. Increased cost, as the turbocharged engines are very expensive to design, manufacture, and repair than naturally aspirated engines due to their added complexity and higher precision components. Increased heat. The turbochargers generate a lot of heat, which can cause problems with engine cooling and potentially lead to engine damage if not managed properly. Increased stress on engine components. The increased power of and torque provided by turbocharged engines can place additional stress on engine components, leading to increased wear and tear and potentially reducing engine longevity. Turbo lag. Turbo lag is a delay in throttle response that can occur when a turbocharged engine is accelerating from low RPM due to the time it takes for the turbocharger to spool up and start generating boost. Future directions: electrification. Hybrid and electric power are becoming increasingly common, and turbocharging may play a role in improving their performance and efficiency. Advanced materials. The use of advanced materials such as ceramic turbine blades and titanium aluminum compressor wheels can improve the efficiency and durability of turbochargers. Integration with other technologies. Combining turbocharging with other technologies such as direct fuel injection and variable valve timing can further improve engine performance and efficiency. Optimization through data analysis. The use of data analytics and of artificial intelligence can help optimize engine performance and reduce emissions, allowing for even greater gains in efficiency and performance. Conclusion. In conclusion, turbocharged engines offer a number of advantages over naturally aspirated engines, including the increased horsepower, improved fuel efficiency, and reduced emissions. While there are drawbacks to turbocharging, such as increased complexity and cost, the benefits are significant, particularly in high performance applications. The success of turbocharging in the automotive industry has led to ongoing research and development aimed at improving its performance, efficiency, and reliability. Future directions for turbocharged engine technology include the use of advanced materials, integration with the other technologies, and optimization through data analysis. Overall, turbocharged engines represent a significant technological advancement in the automotive industry and are likely to continue to play an important role in improving engine performance, efficiency, sustainability in the years to come. These are the references that I've taken. First one is MAL Syed, a review of turbocharger and turbo technologies, which was in 2017, and CM Baines and RWA Howlett, turbocharging the gasoline engine, evolution or a revolution, which was published in the year 2018. And KY Chua, CP Lim, and SK Lim have the design and development of a turbocharger for a small displacement engine. This was in 2016. AK Agarwal and Raja Manoharan. This was in the year 2019, which was titled Impact of Turbocharging on Fuel Economy, Emissions, and Engine Durability of a Diesel Engine. And SM Al Zubaidi, Turbocharger Matching for a Engine Performance Improvement, which was in the year 2018. And A. Megwit, Turbocharger Matching and Performance Analysis, Renewable and Sustainable Energy Reviews, which was in the year 2020. Thank you.